Welcome, and settle in gently for a long and quiet collection of rain facts that move slowly through the night. Tonight there is nothing to follow closely and nothing important to remember. Only soft science, drifting at an even pace, like distant rain moving across a calm landscape. A single raindrop can fall at different speeds depending on its size. Some tiny droplets drift so lightly through the air that they almost seem suspended for a moment before continuing downward. As the night continues, these small and peaceful details about rain, clouds, water, and weather will move slowly from one thought to the next. The pace will stay gentle and steady. There will be no sudden turns and no sharp energy. Just quiet observations about one of the softest natural processes on Earth. Rain has existed on Earth for billions of years. Long before forests, cities, or human voices, water was already rising into the atmosphere and returning again to the surface. The cycle moved continuously across oceans, volcanic stone, and early continents. Even now, the same movement continues quietly above every part of the world. The sound of rain changes depending on what it touches. Rain landing on leaves creates a softer pattern than rain falling onto stone. Water striking wood often produces a lower sound than water touching metal. During a storm, thousands of tiny impacts combine into one continuous layer of noise that many people describe as calming. Scientists who study sound sometimes note that steady natural audio can help mask sudden environmental noises. Because rain tends to create consistent frequencies without sharp interruptions, many people find it restful during sleep. Clouds begin with extremely small particles floating in the atmosphere. Tiny bits of dust, sea salt, smoke, or pollen drift through the air and collect water vapor around themselves. These microscopic centers become gathering points for moisture. Over time, enough water forms around them for droplets to appear. Entire clouds can grow from particles too small to notice without magnification. Some rain begins its journey high above mountains where cold air slowly rises along slopes. As air rises, it cools. Cooler air cannot hold as much water vapor as warmer air, so moisture condenses into clouds. This process happens continuously in many parts of the world without drawing attention to itself. In tropical regions, warm surfaces often heat the air above them during the day. That warm air rises slowly upward carrying invisible moisture. Later, when temperatures shift, rain forms and returns water to the ground. In many equatorial forests, this cycle repeats so regularly that afternoon rain becomes part of the natural rhythm of life. Raindrops are not shaped like tears, despite the common image used in drawings. Small raindrops are usually close to spherical because surface tension pulls water evenly inward. Larger drops flatten slightly underneath as they fall through the air. Very large drops can even break apart into smaller ones before reaching the ground. The smell that arrives before rainfall has a scientific explanation. Dry soil contains compounds released by bacteria and plants. When rain approaches, tiny droplets and moving air lift some of these particles upward. Humans can often detect this earthy scent even before heavy rain begins. Scientists call one part of this familiar smell petrichor. Rainfall helps regulate temperature across the planet. Water absorbs and releases heat more slowly than many other materials. Because of this property, rainy regions often experience more gradual temperature changes compared to dry inland deserts. Clouds themselves also affect temperature by reflecting sunlight during the day and trapping warmth overnight. Some deserts receive rain only a few times each year. Yet even brief rainfall can awaken seeds that have remained inactive beneath the ground for months or years. Tiny plants appear quickly after moisture arrives. Insects emerge. The landscape changes quietly for a short period before returning again to dryness. The average cloud is far heavier than it appears. Even a soft white cloud drifting overhead may contain thousands of kilograms of water spread across countless microscopic droplets. The droplets remain suspended because they are so small and because air currents continue moving upward beneath them. Rain can begin high in the atmosphere and never reach the ground. In very dry regions, falling droplets sometimes evaporate before arriving at the surface. From a distance, these fading trails beneath clouds can look like soft gray curtains hanging in the sky. Meteorologists call this virga. Ocean evaporation provides most of the moisture for Earth's rainfall. Sunlight warms the surface of oceans and lakes, allowing water molecules to escape upward into the air. Winds then carry that invisible moisture across enormous distances. Rain falling over mountains or forests may have begun as seawater drifting silently through the atmosphere days earlier. Different places hear rain differently because architecture changes sound. Rain on tiled roofs creates a sharper rhythm than rain on fabric shelters. Dense forests absorb sound softly, while empty streets echo more clearly during storms. Even the spacing between buildings affects the way rainfall is heard. In colder regions, rain sometimes freezes on contact with surfaces. This process creates a smooth layer of ice over trees, roads, and wires. The ice forms gradually as liquid droplets spread and harden almost instantly. Entire landscapes can become reflective and silent beneath this thin frozen coating. Some of the wettest places on Earth receive rain almost daily for long periods of the year. Clouds moving against mountains release continuous moisture because rising air cools repeatedly in the same location. Over time, these regions develop thick vegetation adapted to constant rainfall and high humidity. Mosses, ferns, and dense forests often thrive there. Gentle rain can improve visibility in one way while reducing it in another. Rain removes tiny dust particles from the atmosphere, making the air cleaner after storms. At the same time, falling water scatters light and softens distant edges. Many landscapes appear quieter and less detailed during rainfall because outlines blur gently behind moving drops. The largest raindrops usually form in warm tropical storms. In these systems, powerful upward air currents keep droplets suspended longer, allowing them to gather additional moisture before falling. Eventually they become too heavy to remain aloft and descend rapidly toward the surface. Rain has influenced architecture for thousands of years. Roof angles, drainage channels, stone roads, and raised foundations were all shaped partly by local weather patterns. In rainy climates, buildings often develop deeper overhangs and stronger water pathways to protect walls and entrances from constant moisture. Some animals respond to rain long before it begins. Changes in air pressure and humidity affect insects, birds, and amphibians. Frogs often become more active during wet conditions because moisture protects their skin. Certain birds fly lower before storms because shifting air pressure influences insect movement. The sound known as white noise shares similarities with steady rainfall. Both contain broad ranges of frequencies layered together evenly. Because the brain does not need to focus intensely on unpredictable changes, consistent sounds may encourage relaxation in some environments. This is one reason recordings of rainfall are commonly used during sleep. Rainwater itself is usually very pure before touching the ground. During evaporation, salts and many impurities remain behind. As moisture condenses into clouds, the resulting droplets contain relatively clean water. However, while falling through the atmosphere, rain can collect particles and gases from the surrounding air. Lightning sometimes occurs inside clouds without visible strikes reaching the ground. During these moments, entire clouds pulse softly with internal light. From far away, the illumination can look muted and distant, almost silent behind layers of rain. Many forests create part of their own rainfall. Trees release water vapor through tiny openings in their leaves during a process called transpiration. In large forests, this moisture contributes significantly to local humidity and cloud formation. Some rain falling over forests may have recently passed through the leaves of nearby trees. The steady movement of rain has shaped landscapes for millions of years. Tiny droplets striking rock and soil gradually loosen particles. Streams form. Valleys deepen slowly. Sediment travels across continents toward oceans. Much of Earth's surface has been quietly carved by water over immense periods of time. In cities, rain often carries a faint reflective glow at night. Streetlights spread across wet pavement in long blurred patterns because thin layers of water reflect light differently than dry surfaces. Even small amounts of rain can soften the appearance of entire streets after dark. Cold rain feels different from warm rain partly because of evaporation on the skin. As water evaporates, it removes heat from the body. In windy conditions, this cooling effect becomes stronger. Warm tropical rain may feel softer because the surrounding air reduces rapid heat loss. Clouds are constantly changing shape even when they appear still. Air currents move through them continuously, carrying moisture upward and downward. Tiny droplets merge, separate, evaporate, and reform in an endless process invisible to the eye. A cloud viewed for several minutes is never exactly the same cloud twice. Some rainstorms travel enormous distances. Weather systems crossing oceans can continue for days before reaching land. Winds guide moisture across continents in broad, invisible rivers within the atmosphere. Meteorologists sometimes refer to these concentrated pathways as atmospheric rivers because they transport such large amounts of water vapor. Rainfall can slightly alter the scent of forests. Wet leaves release oils more easily, tree bark darkens with moisture, and soil organisms become active near the surface. Together, these small changes create the calm, earthy atmosphere many people notice during quiet, rainy evenings. In ancient times, many civilizations carefully observed rainfall patterns to guide farming seasons. Long before modern forecasting, communities watched clouds, winds, animal behavior, and humidity for signs of approaching rain. These observations became deeply connected to agriculture and daily life. The surface tension of water allows droplets to cling briefly to leaves, windows, and spider webs. Surface tension forms because water molecules attract one another strongly. This property helps raindrops maintain smooth, rounded shapes while moving across surfaces. Rain falling on lakes creates overlapping circular waves that expand outward and disappear. During steady rainfall, thousands of these patterns form and fade every second. The surface becomes covered in temporary motion with no single shape lasting very long. Some of the quietest moments during rainfall happen immediately after heavy storms weaken. Water continues dripping from trees and rooftops even after the clouds begin to thin. The remaining sound becomes softer and more spaced apart, leaving only occasional droplets moving through cool air. In very cold clouds, tiny ice crystals often begin forming before snow or rain reaches the ground. These crystals grow slowly as water vapor attaches to their surfaces. When they become heavy enough, they fall through layers of air that may be warmer or colder depending on altitude. Sometimes the crystals melt into rain before arriving at the surface. Other times they remain frozen the entire way down. Meteorologists divide clouds into categories partly based on altitude. High clouds made of ice crystals drift far above the ground and often appear thin and soft. Middle clouds contain mixtures of ice and liquid water. Lower clouds usually consist mostly of liquid droplets. Rain-producing clouds often develop vertically through several atmospheric layers at once. Some raindrops collide while falling. When two droplets meet, they may combine into a larger drop or break apart into smaller droplets depending on speed and size. Entire cloud systems are shaped by countless microscopic collisions occurring continuously in the air. The atmosphere contains water in several forms at once. Invisible vapor moves between molecules of air. Tiny liquid droplets gather into clouds. Ice crystals drift at higher elevations. All three states can exist together inside the same weather system without drawing attention to themselves. On quiet nights, light rain sometimes appears almost motionless beneath streetlights. This visual effect happens because the human eye cannot easily track individual droplets in dim light. Instead, rainfall becomes a soft shimmering texture moving steadily through darkness. Some regions experience seasonal rain so regular that ecosystems depend completely on them. Plants time their growth cycles around moisture patterns. Rivers expand and contract according to annual rainfall. Animals migrate or reproduce during wetter months when water and vegetation become more abundant. The sound of distant rain differs from nearby rainfall. Faraway rain often loses sharp detail because high-frequency sounds fade first over distance. What remains is a softer low continuous texture, similar to wind moving through trees or waves breaking far from shore. Rain clouds can stretch across enormous areas. A single weather system may cover multiple countries or entire coastlines at once. From space, these systems appear as vast moving formations slowly rotating above oceans and continents. Yet from the ground, only a small section of sky is visible at any moment. Humidity changes the way rain feels against the skin. In dry air, moisture evaporates quickly and creates a cooler sensation. In humid air, evaporation slows, and rain may feel softer and warmer even at the same temperature. Some plants collect rainwater directly through the shapes of their leaves. Broad leaves guide droplets toward stems and roots. Certain desert plants are especially efficient at directing rare rainfall into the soil beneath them. Over long periods, these small adaptations help plants survive difficult climates. Rain often appears heavier against dark backgrounds than bright ones. Water droplets reflect and scatter light differently depending on surroundings. A storm passing in front of dense trees may look thicker than the same rain falling across pale open sky. Many insects become quieter during rainfall because moving water interferes with delicate wing movement. Some species shelter beneath leaves or inside bark until conditions become calmer. After rain ends, nighttime insect sounds often return gradually as surfaces begin drying again. The first rainfall after long dry periods sometimes creates temporary streams in places that remain empty most of the year. Water flows briefly through stone channels and low valleys before disappearing again into soil or evaporation. These short-lived streams may only exist for hours or days. Some clouds release rain unevenly. One neighborhood may experience steady rainfall while another nearby area remains dry. Small differences in temperature, elevation, and air movement influence where droplets gather densely enough to fall. Rain can carry nutrients from the atmosphere into soil and water systems. Tiny particles containing nitrogen occasionally dissolve into rainwater during storms. Lightning can also help convert atmospheric nitrogen into forms usable by plants. Over long periods, these quiet processes contribute to ecosystem growth. Certain forests remain covered in mist and light rain for much of the year. Moisture drifts continuously through trees without ever becoming a dramatic storm. Moss grows thickly on branches and stones because surfaces rarely become fully dry. The scent of rain on pavement differs from the scent of rain on soil because different materials release different compounds when wet. Stone, asphalt, wood, and earth all interact with moisture in their own quiet ways. Even temperature changes the character of these smells. Warm pavement after summer rain creates a different atmosphere than cool winter sidewalks beneath drizzle. Raindrops can act briefly like tiny lenses. Water-bending light sometimes creates miniature reflections or distortions on windows and leaves. Entire landscapes may appear stretched or blurred through moving droplets during storms. The atmosphere holds more water vapor when temperatures are warmer. This is one reason tropical regions can produce extremely heavy rainfall. Warm air stores larger amounts of moisture before condensation finally begins. Some birds continue flying during light rain with little difficulty because feathers overlap in ways that shed water efficiently. Oils produced by many birds help reduce moisture absorption and maintain insulation. After storms, birds often spend long periods smoothing and cleaning their feathers carefully. Rainfall has influenced human sleep for centuries. Long before recorded sound or electric devices, many people rested beneath the steady natural noise of storms outside homes or shelters. Even now, recordings of rainfall remain among the most commonly used sleep sounds around the world. The edges of storm clouds sometimes appear brighter than their centers because sunlight scatters around dense moisture. These softer glowing outlines can remain visible even when the interior of the cloud looks dark and heavy with rain. Some mountain regions create rain shadows. Moist air rises along one side of a mountain range and releases moisture as rainfall. By the time the air crosses over the peaks and descends the other side, it has become drier. This often leaves one side green and wet while the opposite side remains arid. Rainwater slowly moving through soil becomes groundwater. Some of this underground water may remain beneath the surface for years before emerging again through springs, rivers, or wells. The movement is extremely gradual in certain rock formations. In tropical forests, rain falling through upper leaves often takes time to reach the ground. Water collects on branches, drips slowly downward, and spreads across layers of vegetation. During heavy rainfall, the forest floor may still receive water in soft delayed patterns. The gentle gray appearance of rainy skies comes from light scattering through thick layers of cloud droplets. Instead of direct sunlight traveling clearly through the atmosphere, light spreads more evenly in many directions, reducing shadows and contrast. Some storms produce rain with remarkably consistent droplet sizes. Other storms contain wide mixtures ranging from fine mist to large heavy drops. Meteorologists study these differences because droplet size affects visibility, sound, and rainfall intensity. Rain can cool entire cities after periods of heat. Wet surfaces absorb energy differently than dry pavement and concrete. Evaporation also removes heat from the environment. Temperatures often drop noticeably after long summer rainstorms. The movement of water through Earth's atmosphere is part of a larger planetary cycle powered mostly by sunlight. Solar energy drives evaporation from oceans and lakes. Winds transport moisture. Cooling forms clouds. Gravity returns water again as rain or snow. The process continues continuously without pause. Very light rain is sometimes called drizzle. Drizzle droplets are smaller than typical raindrops and fall more slowly. Because the droplets are so fine, drizzle often seems to float sideways in gentle wind rather than falling directly downward. Some ancient stone structures still show marks created by centuries of rainfall. Water slowly dissolves certain minerals and smooths rough surfaces over time. Even hard rock changes gradually beneath continuous exposure to moisture. Rainbows appear when sunlight enters water droplets and bends, reflects internally, and exits again at different angles. Each droplet separates light into colors briefly before the image disappears as viewing angles shift. Millions of droplets together create the soft curved band seen after rain. The quiet after rainfall often feels different because moisture changes sound behavior. Wet ground absorbs more noise than dry surfaces. Leaves become heavier and move less in the wind. Dust settles from the air. Together, these small changes create a softer environment. Some lakes depend heavily on seasonal rain for survival. Water levels rise gradually during wet months and decline again during dry periods. Fish, birds, and surrounding plants adapt to these repeating changes in depth and shoreline shape. During nighttime storms, lightning may illuminate clouds from within without revealing clear shapes. Entire sections of sky brighten softly for a moment and fade again behind curtains of rain. The effect can appear distant and muted through thick cloud layers. Rainfall intensity is measured using gauges that collect water over time. Meteorologists compare how much rain falls during specific periods to understand storm behavior and flooding risk. Even small differences in rainfall rates can greatly affect rivers and soil saturation. Some grasses recover quickly after rain because their narrow leaves lose water more slowly than broad leaves under sunlight. Moisture stored in soil also remains accessible to shallow root systems for short periods after storms. The sound of rain inside vehicles changes with speed and surface material. Rain on stationary metal roofs produces one texture, while moving through storms creates shifting patterns across glass and steel. Different vehicle shapes alter how droplets spread and flow. Cloud droplets are so small that many float for long periods before joining larger drops. A single visible raindrop may contain moisture gathered from millions of microscopic cloud particles combined together. In polar regions, snowfall often replaces rainfall because air temperatures remain too low for liquid water. Yet even in these cold environments, moisture still cycles continuously through evaporation, clouds, and precipitation. Frozen water simply becomes the dominant form. Some deserts experience rainstorms so rare that dry ground cannot absorb water quickly when rain finally arrives. Instead, water flows rapidly across the surface, forming sudden temporary floods before disappearing again. Rain falling into oceans may seem unimportant compared to the size of the sea, yet global rainfall and evaporation remain closely balanced over long periods. Water leaving oceans through evaporation eventually returns through rain, rivers, and melting ice. The oldest water moving through today's rain cycle may have circulated repeatedly for millions of years. Molecules evaporate, condense, freeze, melt, and travel endlessly through oceans, rivers, clouds, glacier, plants, and air. The same water continues moving quietly through changing landscapes across immense stretches of time. In many coastal regions, rain arrives differently than it does inland. Oceans' moderate temperature changes, and moist sea air often moves gradually toward land during certain seasons. As this air cools, clouds develop and rainfall begins. Coastal storms can linger for long periods because fresh moisture continues arriving from the water nearby. The appearance of rain through windows changes with lighting conditions. During daylight, individual droplets may stand out sharply against bright skies. At night, reflections from indoor lamps or distant streetlights blur the droplets into slow-moving patterns across the glass. Some leaves are shaped in ways that allow water to fall from pointed tips. This helps prevent water from collecting too heavily on the surface. In tropical rainforests, many plants develop these shapes over long periods because regular rainfall made efficient drainage important. The sound of rain on forests often contains layers. Water first strikes the upper canopy, then drips through branches and lower leaves before reaching the ground. Each level softens and spreads the sound differently. What begins as a direct rainfall becomes a slow sequence of quieter droplets moving downward through the trees. Fog and rain are closely related. Fog forms when tiny droplets remain suspended near the ground instead of falling. The droplets are extremely small and light, allowing them to drift through the air almost like clouds resting on the surface of the earth. Some ancient cultures measured time partly through rainy seasons instead of fixed monthly calendars. Agricultural work depended so closely on rainfall that weather patterns became deeply connected to the structure of daily life and long-term planning. Rain can reveal hidden textures on stone and wood. Dry surfaces often appear flat and pale, but moisture darkens materials unevenly and highlights grain, cracks, and patterns. Old paths, walls, and tree trunks sometimes look more detailed during wet weather. During gentle rain, lakes and ponds may appear smoother from a distance even while countless droplets disturb the surface. The repeated impacts create such fine uniform movement that the water loses sharp reflections and becomes soft and muted instead. Some seeds require rainfall before germination can begin. Moisture softens outer coatings and activates chemical processes inside the seed. Until enough water arrives, the seed remains inactive beneath soil or sand, sometimes for very long periods. The atmosphere continuously exchanges moisture between regions. Water evaporating from one continent may later fall as rain across another. Winds transport invisible vapor over mountains, deserts, and oceans in steady global circulation patterns. Rain falling through warm city air sometimes creates rising steam from roads and rooftops. This happens because water evaporates quickly from surfaces that stored heat earlier in the day. The effect is often most visible after summer storms. Clouds often appear lower during rainy weather because moisture fills more of the lower atmosphere. The boundary between sky and land feels softer when clouds descend closer to hills, buildings, or treetops. Many freshwater rivers depend almost entirely on rainfall patterns. In wet years they expand and move more strongly. During dry years they narrow and slow. Entire ecosystems respond gradually to these long-term shifts in available water. The rhythm of rainfall is rarely perfectly regular. Even steady storms contain subtle variations as droplet sizes change and wind shifts slightly. The human brain often interprets these soft, irregular patterns as natural and calming because they remain gentle without becoming repetitive in a mechanical way. Some birds rest quietly during long rainstorms to conserve energy. Wet feathers increase weight and reduce insulation, so remaining sheltered can help maintain body temperature. Trees and dense shrubs provide protection during extended rainfall. Rainwater sometimes gathers temporarily on spider webs. Tiny droplets cling to silk strands because of surface tension. Morning webs after light rain can appear covered in silver points reflecting soft light. The smell of forests after rainfall partly comes from organic compounds released by plants. Moisture helps carry these molecules into the air where they become easier to notice. Pine forests, grasslands, and tropical jungles each produce distinct scents during wet weather. Some regions experience monsoon systems driven by seasonal temperature differences between land and ocean. Warm land surfaces pull moist ocean air inward during certain times of year, leading to prolonged periods of rainfall. These systems influence agriculture, rivers, and daily routines for millions of people. Light rain can continue even after clouds begin thinning because droplets already formed high in the atmosphere continue falling long after the storm weakens. This creates moments where sunlight and rainfall coexist softly together. In cold climates, snow sometimes falls silently because ice crystals land more gently than liquid raindrops. Rain usually creates clearer sound because liquid water impacts surfaces with greater force. Wet snow, however, may produce soft muffled textures somewhere between the two. The color of rainy skies changes throughout the day. Morning rain often appears pale blue-gray. Evening rain may become silver, orange, or deep violet depending on the position of the sun behind clouds. Thick moisture layers scatter light continuously as daylight shifts. Some frogs remain inactive underground during dry periods and emerge after rainfall returns. Moist conditions help protect their skin and support breeding environments such as temporary pools and wetlands. Entire nighttime soundscapes may change after rain awakens these animals. Raindrops can merge while sliding down windows. Small droplets combine into larger streams that move more quickly under gravity. The paths they leave behind constantly change as new droplets join or separate along the surface. Rain has shaped soil distribution across continents. Over immense periods, moving water carried minerals, clay, and organic matter into valleys and plains. Fertile agricultural regions often formed where rainfall and rivers deposited nutrients gradually year after year. Some clouds produce rain that evaporates only partially before reaching the ground. This creates cooler air beneath storms because evaporation absorbs heat. The cooled air then sinks downward and spreads outward along the surface. The gentle haze visible during rain comes from countless droplets suspended in the air. Even when individual drops cannot be seen clearly, moisture scatters light and softens distant objects. Mountains, buildings, and trees gradually fade into gray during prolonged rainfall. In tropical storms, enormous quantities of water move through the atmosphere continuously. Yet the droplets themselves remain surprisingly small most of the time. A large storm contains vast numbers of tiny particles rather than a few large masses of water. Rainfall affects the behavior of soil organisms beneath the ground. Worms, insects, fungi, and bacteria all respond to changing moisture levels. Wet soil allows nutrients and dissolved minerals to move more easily between roots and microorganisms. The sound of rain heard from indoors often changes depending on insulation and building materials. Thick walls soften outside textures while thin roofs may amplify them. Attics, tents, cabins, and apartments each create distinct versions of the same storm. Some valleys receive frequent mist because cool air settles lower overnight. Moisture condenses close to the ground and remains trapped until sunlight warms the air again. Morning fog in these places can persist quietly for hours. Rain can slightly change the color of oceans and lakes. Cloud cover reduces reflected sunlight, while surface ripples alter the way light moves across water. Deep blue areas may become gray or silver beneath storms. Many desert animals obtain water indirectly from rainfall through plants, insects, or temporary pools rather than drinking frequently from rivers. Adaptations for conserving moisture allow survival in regions where rain arrives only rarely. The atmosphere contains rivers of air moving at different speeds and directions. Rain clouds interact with these currents continuously. Wind-shaped cloud edges transport moisture and influence where storms strengthen or weaken. During calm rainfall, distant sounds sometimes travel farther because cool, moist air bends sound differently than hot, dry air. The environment becomes quieter overall, allowing certain noises to seem clearer through the rain. Some mountain forests capture moisture directly from clouds. Tiny droplets drifting through fog settle onto leaves and branches before dripping into the soil below. In these environments, clouds themselves become an important water source even without heavy rainfall. Raindrops striking soil can slowly move tiny particles over time. Though each impact is small, millions of droplets gradually loosen and redistribute surface material. This quiet process contributes to erosion across long timescales. In cities at night, wet roads often appear darker because water reduces scattered reflection from rough surfaces. At the same time, direct reflections from lights become brighter and longer. This contrast gives rainy streets their familiar glowing appearance. Some ancient forests experience such regular rainfall that thick layers of moss cover rocks, trunks, and fallen branches almost continuously. Moisture remains trapped beneath dense canopies where sunlight rarely reaches the ground directly. The cooling effect after rain partly comes from evaporation and partly from reduced sunlight. Thick clouds block incoming solar energy while wet surfaces release heat differently than dry ground. Air temperatures often remain lower for some time after storms pass. Certain grasses bend beneath rainfall and then slowly rise again as water drains away. Flexible stems reduce damage during heavy storms by allowing movement instead of resisting force completely. Rain falling on different bodies of water creates different sound textures. Small ponds produce sharper individual impacts than large oceans where waves and wind blend the noise into broader continuous sound. Streams and rivers add flowing movement beneath the rainfall itself. Some insects detect humidity changes through sensitive structures on their bodies. Rising moisture levels before storms can influence movement, feeding, and sheltering behavior long before rainfall actually begins. The process of condensation releases tiny amounts of heat into the atmosphere. As water vapor becomes liquid droplets inside clouds, energy transfers into surrounding air. This subtle release of heat helps fuel further cloud development in some storms. Gentle rain during nighttime often feels slower because visual references become limited in darkness. Without clear outlines or distant movement, attention shifts more toward sound and atmosphere than toward visible detail. Over long periods, rainfall patterns influence the shapes of entire ecosystems. Dense forests grow where moisture remains abundant. Grasslands develop where rain arrives seasonally. Deserts persist where evaporation greatly exceeds precipitation. Water distribution quietly guides the structure of landscapes across the planet. Some of the smallest raindrops fall so slowly that weak upward air currents can hold them suspended for extended periods. These droplets drift gently through clouds before eventually joining larger drops or evaporating again into invisible vapor. The atmosphere is constantly exchanging water between visible and invisible forms. The texture of rain changes depending on wind speed. During still conditions, droplets fall almost vertically and produce soft, even patterns. In stronger winds, rain moves diagonally and strikes surfaces at changing angles, creating shifting rhythms against roofs, trees, and windows. Many rivers begin as rainfall collected in high elevations. Water gathers from clouds over mountains and slowly flows downhill through streams and channels. Tiny trickles combine into larger currents that eventually reach lakes or oceans far away from where the rain first fell. Rainfall affects the brightness of natural colors. Wet leaves reflect light differently than dry leaves, often appearing deeper green after storms. Stones darken with moisture, tree bark becomes richer in tone, and soil takes on softer earthy shades beneath rain. Some clouds form in layers so smooth and even that they cover the sky almost completely. These wide cloud sheets often bring long periods of gentle, steady rain rather than sudden storms. The light beneath them becomes quiet and diffused with very few shadows. In warm climates, rain evaporating from streets and buildings can slightly increase local humidity after storms. Moisture returns upward into the air from surfaces heated earlier by sunlight. Even after rainfall ends, evaporation quietly continues. The movement of rain through forests sometimes creates delayed dripping long after storms weaken. Water stored on branches and leaves slowly falls in separate droplets over time. A forest can continue sounding rainy even after open skies nearby have already cleared. Some birds use rainwater collected on leaves for drinking and bathing. Small pools forming naturally in plants provide temporary water sources throughout forests and gardens after storms. The smell associated with approaching rain is often strongest after dry weather because oils and particles accumulate on surfaces over time. The first moisture releases these materials into the air more noticeably than later rainfall during extended wet periods. Raindrops accelerate only up to a certain speed while falling. Air resistance eventually balances gravity, causing droplets to reach what scientists call terminal velocity. Larger drops fall faster than smaller ones, though extremely large drops often break apart before reaching the ground. Certain deserts experience cool nighttime temperatures that allow moisture to condense directly from the air onto rocks and plants. Even in places with little rainfall, atmospheric water can still enter ecosystems through dew and fog. Clouds sometimes appear darker underneath because light has more difficulty passing through thicker moisture layers. The upper parts of clouds may still reflect sunlight brightly while lower sections remain shaded and gray. Rainwater flowing through forests carries nutrients into streams and rivers. Leaves, soil minerals, and organic material dissolve gradually into moving water, connecting land ecosystems with freshwater environments downstream. Some storms remain almost stationary over one area when atmospheric winds weaken or balance each other. These slow-moving systems can produce long periods of uninterrupted rainfall while nearby regions stay comparatively dry. The sound of rain heard from beneath blankets or inside quiet rooms often becomes softer because fabrics absorb higher frequencies. Lower continuous tones remain more noticeable, creating the muted calming effect many people associate with rainy nights indoors. In certain climates, brief rain showers occur nearly every afternoon during warmer months. Solar heating throughout the day lifts moist air upward until clouds develop and release rain before evening temperatures cool again. These regular cycles become familiar parts of local daily life. The first scientific rain gauges were simple containers used to measure collected water depth. Over time, meteorologists developed more precise instruments capable of recording rainfall intensity, timing, and droplet characteristics automatically. Rain falling across open fields can create moving patterns visible from far away. Slight changes in wind direction or rainfall intensity form darker and lighter sections traveling slowly across the landscape. Some tree bark absorbs rainwater while other bark types repel it more effectively. Texture, thickness, and chemical composition influence how moisture interacts with different species. After storms, forests display many subtle variations in color and wetness from tree to tree. The atmosphere contains an enormous amount of water vapor at any moment, though it is spread thinly through vast volumes of air. If all atmospheric moisture condensed at once, it would cover the planet in a layer of water several centimeters deep. During light rain, puddles often reveal the direction of wind through ripples moving across their surfaces. Tiny waves travel outward differently depending on droplet angle and air movement above the water. Some rainstorms produce a low continuous background sound without noticeable individual drops. This happens when rainfall is dense and uniform enough that separate impacts blend completely into one broad texture of noise. In tropical regions, warm rain sometimes falls while sunlight remains visible through breaks in clouds. The combination of bright light and falling droplets creates glowing reflections on leaves, roads, and water surfaces. Certain flowers close partially during rain to protect pollen from excessive moisture. Others remain open and rely on rainwater to wash dust and particles from their surfaces. Plant responses to rainfall vary widely between species and climates. The cooling scent after storms partly comes from changes in humidity and temperature affecting human perception. Cooler moist air carries smells differently than warm dry air, often making natural scents seem clearer and softer. Some regions experience freezing rain when snowflakes melt into liquid in warmer air layers and then fall into shallow cold air near the ground. The droplets remain liquid until contact with surfaces causes instant freezing. Trees and roads may become coated in smooth, transparent ice. Rainwater entering soil moves at different speeds depending on ground composition. Sandy soil allows water to pass quickly downward, while clay slows movement and holds moisture near the surface longer. These differences strongly influence plant growth and groundwater storage. The sound of distant thunder often becomes softer and longer during rainy conditions because moisture and clouds scatter the vibrations through the atmosphere. Sharp cracks nearby turn into rolling low tones farther away. Some islands receive much of their fresh water entirely from rainfall because rivers and lakes remain limited in size. Collected rainwater becomes an important resource for drinking and agriculture in these regions. Rain can reduce airborne dust significantly. Falling droplets capture particles suspended in the atmosphere and bring them to the ground. Air often feels cleaner after storms because fewer small particles remain floating overhead. Many wetlands depend on regular rainfall to maintain water levels and support wildlife. Marshes, swamps, and seasonal pools provide habitats for birds, insects, fish, and amphibians adapted to changing moisture conditions. Clouds drifting over cities sometimes produce uneven rainfall because buildings influence air movement. Tall structures alter wind patterns and temperature distribution slightly, shaping how moisture develops in urban areas. The movement of rain across oceans can only be fully appreciated from above. Satellite images reveal broad curved storm systems covering immense areas of water. Yet inside those systems, rainfall still consists of countless tiny droplets falling quietly through air. Some mosses absorb water directly across their surfaces rather than relying mainly on roots. During rainy periods, these plants swell softly with moisture and remain green even in shaded environments. Rainfall can influence animal migration timing. Certain species begin moving when seasonal rains refill rivers, flood plains, or temporary feeding grounds. Moisture patterns guide large ecological rhythms around the world. The reflective surface of wet stone often makes nighttime landscapes appear calmer and softer. Moonlight or artificial light spreads across damp surfaces in muted patterns rather than sharp, dry reflections. Some clouds contain supercooled liquid water, meaning droplets remain unfrozen even below normal freezing temperatures. When these droplets touch solid surfaces or particles, they may freeze rapidly into ice. Rain heard beneath tree cover usually sounds quieter than open rainfall because leaves intercept much of the water before it reaches the ground. Forest canopies act like soft natural filters for falling moisture. In many climates, morning rain differs from evening rain because temperature patterns change throughout the day. Cooler morning air often produces lighter mist or drizzle, while daytime heating may support taller storm clouds later in the afternoon. The atmosphere continuously balances evaporation and precipitation across the planet. Some regions lose more water through evaporation than they receive from rain, while others receive abundant rainfall compared to moisture loss. These long-term differences shape global climate zones. Certain river valleys become filled with low cloud during rainy weather because cool moist air settles and remains trapped between surrounding hills. The landscape appears partially hidden beneath smooth layers of gray mist. Raindrops striking water surfaces briefly trap tiny air bubbles beneath them. Some of the soft crackling sounds heard during rainfall over lakes or puddles come from these bubbles forming and collapsing rapidly. The edges of leaves often collect droplets after rain because surface tension holds water in place. Morning sunlight later evaporates these remaining droplets slowly into the air again. Some ancient civilizations designed stone channels specifically to guide rainwater through cities and farms. Careful water management allowed communities to store moisture from seasonal storms for later use during dry periods. Rain clouds sometimes stretch vertically many kilometers into the atmosphere. Strong upward air currents carry moisture high above the ground where temperatures become extremely cold. Different layers within the same cloud may contain liquid water, snow, and ice simultaneously. The feeling of calm many people experience during rain may partly come from reduced sensory activity outdoors. Streets quiet down, movement slows, visibility softens, and natural sounds become more consistent. The environment itself encourages a gentler pace. Over very long time scales, rainfall contributes to the formation of caves. Slightly acidic water slowly dissolves certain rock types as it passes underground. Tiny changes accumulate gradually until large caverns and stone formations appear beneath the surface. Light rain continuing through the night often blends into dreams and half-sleep because the sound remains steady without demanding attention. Individual droplets disappear into a wider texture of soft continuous motion moving quietly through darkness. Some parts of the world experience cloud forests where moisture remains suspended in the air almost constantly. Trees there are often covered in mosses, lichens, and ferns that absorb water directly from mist and rainfall. The atmosphere inside these forests feels cool, quiet, and continuously damp beneath dense layers of leaves. Rain moving across grasslands creates subtle waves of motion as droplets bend tall stems in shifting patterns. Wind passing through wet grass afterward often sounds softer because moisture weighs the blades down and reduces sharper rustling noises. The atmosphere near oceans usually contains more moisture than inland air because evaporation occurs continuously from the sea surface. Even on calm days, invisible water vapor rises upward from waves and drifts inland with changing winds. Some rainfall begins from clouds so high and thin that the process remains invisible to people on the ground. Ice crystals gather gradually, fall into lower layers, melt into liquid droplets, and continue downward as rain without revealing the full journey above. The surface of tree leaves contains tiny structures that influence how water spreads across them. Certain plants repel water strongly, causing droplets to bead and roll away quickly. Others allow moisture to spread thinly across broader surfaces. During long rainy periods, rivers often change color slightly because flowing water carries suspended soil and minerals downstream. Fast-moving water appears more opaque than calm, clear streams due to the increased movement of tiny particles. Rainfall cools forests more slowly than open cities because trees already provide shade and moisture through transpiration. Urban areas built from stone, metal, and pavement often release stored heat rapidly during storms, leading to noticeable temperature drops after rain begins. Some regions receive rain generated partly by nearby lakes. Large bodies of water release moisture into cold air moving overhead. As the air cools further, clouds form and precipitation develops downwind from the lake. The scent of wet wood differs from dry wood because moisture releases trapped organic compounds into the air. Old cabins, fences, forest floors, and wooden rooftops each develop distinct smells during rain depending on age and tree type. Many small animals remain hidden during storms to conserve body heat. Rain increases heat loss for creatures with small body sizes because water removes warmth efficiently from exposed surfaces. Sheltering beneath stones, bark, or soil helps reduce this effect. The edges of puddles often reveal slight slopes in the ground that go unnoticed during dry weather. Water naturally settles into lower areas, quietly outlining the shape of streets, paths, and landscapes after rain. Some rain clouds rotate slowly due to large atmospheric wind patterns. Even gentle rotation influences how moisture moves through storms and where rainfall becomes heaviest. Satellite images often reveal broad curved structures hidden from ground-level view. Cloud droplets form around condensation nuclei, which are tiny particles floating in the atmosphere. Without these microscopic surfaces, water vapor would have more difficulty condensing into visible droplets. Dust, salt, smoke, and pollen all contribute to cloud formation in different environments. Rain falling into forests sometimes creates temporary streams along tree bark. Water flows downward in thin lines toward roots, carrying moisture efficiently into the soil surrounding the trunk. In colder climates, rain mixed with snow can produce soft muffled weather sounds. Liquid droplets strike surfaces while snow absorbs and softens surrounding noise. The combination creates a quieter atmosphere than heavy rain alone. Some regions experience misty rainfall made of extremely fine droplets that seem almost suspended in the air. Instead of distinct falling drops, the environment becomes filled with moisture moving slowly through wind and light. The process of evaporation continues even during rainfall in some conditions. Warm surfaces and moving air allow certain droplets to return immediately to vapor while other water continues falling nearby. The atmosphere constantly exchanges moisture in both directions at once. Rainwater entering underground rock formations may travel for very long distances before reappearing. Some springs release water that entered the ground decades earlier after slowly moving through porous stone layers. The sound of rain against umbrellas changes depending on fabric tension and droplet size. Tight surfaces create sharper tapping sounds while softer materials absorb more impact and produce gentler textures. Certain mountain peaks generate clouds almost daily because rising air cools repeatedly at the same elevation. Moisture condenses along slopes and drifts around high forests and ridges in continuous cycles. Wet soil often appears darker because water changes how light reflects from the surface. Moisture reduces scattered reflection and allows deeper tones within the soil to become visible. Some birds sing less during rainfall because sound travels differently through wet moving air and dense background noise. After storms weaken, bird calls gradually return as environmental sounds become clearer again. Rain has slowly shaped coastlines by feeding rivers that carry sediment toward oceans. Over immense timescales, moving water builds deltas, smooths rocks, and changes shorelines grain by grain. The coolness people feel near waterfalls and heavy rain partly comes from tiny droplets suspended in the air. These droplets evaporate against skin and remove heat continuously from the surrounding environment. Some deserts contain dry riverbeds that fill suddenly after distant rainfall many kilometers away. Water traveling through narrow channels can arrive long after storms have ended elsewhere. The appearance of distant hills during rain often becomes layered and faded because moisture scatters light through the atmosphere. Nearby objects remain clearer while farther landscapes soften gradually into pale gray tones. Clouds can sometimes produce both rain and snow simultaneously in different locations beneath the same storm. Temperature variations near the ground determine whether falling precipitation remains liquid or frozen before reaching the surface. Rainwater moving through leaves occasionally collects nutrients before dripping into the soil below. Forest ecosystems recycle minerals continuously through these gentle exchanges between canopy, rainfall, and ground. Some stones release trapped heat slowly during nighttime rain, creating faint rising warmth near roads and buildings after hot days. Evaporation from these surfaces contributes to the cool damp feeling common after evening storms. The atmosphere over tropical oceans often contains towering clouds reaching very high altitudes. Strong upward air currents support continuous cloud growth as warm, moist air rises from the sea surface below. Light rain during dawn can make landscapes appear almost colorless for short periods because thick cloud cover diffuses sunlight evenly across the environment. Shadows disappear and outlines soften beneath the pale morning sky. Some insects use rainwater droplets as temporary drinking sources. Tiny amounts of moisture trapped on leaves, stones, or grass blades become important resources for small creatures after storms. The sound of rain in narrow streets differs from rainfall in open spaces because buildings reflect and contain echoes. Urban rain often feels denser acoustically due to repeated reflections between walls and pavement. Certain grasses and plants recover quickly after drought because their roots remain dormant but alive beneath dry soil. Once rainfall returns, growth resumes surprisingly fast as moisture spreads underground. Rain clouds viewed from airplanes sometimes resemble broad white landscapes stretching across the horizon. From above, the tops of storms may appear calm and smooth even while heavy rainfall continues far below. The smell of rain near oceans often combines salt air with wet stone, seaweed, and damp sand. Coastal storms carry distinct scents shaped by minerals and organic material from the shoreline. Some wetlands expand dramatically during rainy seasons and then shrink again during dry months. Water levels change slowly over time, reshaping habitats for fish, birds, insects, and plants throughout the year. Raindrops occasionally freeze into tiny ice pellets before reaching the ground when they pass repeatedly through layers of warm and cold air. These pellets bounce differently from liquid rain and create sharper sounds on hard surfaces. The cooling effect of shade becomes stronger after rain because moist air and reduced sunlight combine to lower surface temperatures. Forests, gardens, and stone pathways often feel especially cool during calm, wet afternoons. Some caves contain formations created entirely by slow dripping water. Minerals dissolved in rainwater accumulate gradually over thousands of years, building delicate stone shapes drop by drop. Rainfall intensity can vary greatly within short distances because cloud structures constantly shift. One street may experience heavy rain while another nearby receives only light drizzle beneath the same weather system. The quiet reflective appearance of wet pavement comes from thin layers of water smoothing rough surfaces. Light travels more evenly across the water film, producing soft mirrored reflections beneath streetlights and windows. Some tropical trees have smooth bark that helps rainwater flow downward quickly instead of soaking into the surface. Efficient drainage reduces moisture buildup and limits the growth of certain fungi or insects. The atmosphere contains countless invisible movements affecting rainfall at every moment. Tiny temperature differences, wind shifts, and moisture variations guide where clouds grow, weaken, or release precipitation. Most of these processes remain unnoticed from the ground. Rain drifting across lakes often creates darker patches moving over the surface. These patterns show where droplets disturb the water most densely and where wind changes direction slightly across the lake. Many people notice that indoor spaces feel quieter during rainstorms because outdoor activity decreases at the same time environmental sounds become more uniform. Traffic softens, distant noises fade, and rainfall fills empty spaces with steady texture. The journey of a single water molecule through the rain cycle may include oceans, glacier, rivers, clouds, soil, living plants, and the atmosphere over many thousands or millions of years. Water continues moving patiently through these forms without rest, returning again and again to clouds and rainfall across the earth. Rain falling through warm evening air sometimes creates a faint silver appearance beneath streetlights. Individual droplets reflect small amounts of light as they pass, forming soft vertical lines against the darkness. From a distance, the rain may appear almost like slow-moving mist rather than separate drops. Some plants store rainwater inside thick leaves or stems for later use during dry periods. Desert succulents are especially adapted for this purpose, holding moisture efficiently within their tissues after rare rainfall events. The atmosphere above forests often remains cooler during rainy weather because trees reduce direct sunlight reaching the ground. Moisture released by leaves also contributes to lower surrounding temperatures through evaporation. Rainwater flowing across stone pathways gradually smooths rough surfaces over long periods of time. Even hard rock changes slowly beneath the repeated movement of water carrying tiny particles and minerals. Some storms release rainfall in pulses rather than steady patterns. Brief heavier sections move through clouds and then soften again into lighter drizzle as air currents shift internally. The scent of rain over farmland often includes wet soil, grasses, and plant oils mixed together. Different crops and vegetation types create distinct atmospheric smells after storms. Clouds illuminated by moonlight during nighttime rain can appear softly luminous against darker skies. Thick moisture layers scatter pale light gently through the cloud edges while rain continues falling below. In many regions, rainfall helps clean leaves by washing away dust and pollutants collected during dry weather. Plants often appear brighter and fresher after long rainstorms because their surfaces reflect light more clearly again. Some mountain valleys experience temperature inversions during rainy periods. Cool, dense air settles lower while slightly warmer air remains above, trapping fog and moisture close to the ground. Raindrops landing on calm water briefly create crown-shaped splashes before collapsing back into the surface. These tiny shapes last only fractions of a second but occur continuously during rainfall across lakes and puddles. The atmosphere can transport volcanic ash and desert dust across oceans, where those particles later become condensation nuclei inside clouds. Rain falling far from its original source may contain microscopic material carried through the atmosphere over immense distances. Certain forests remain damp for long periods even after rainfall ends because dense canopies block sunlight and reduce evaporation. Moisture lingers on leaves, bark, and soil beneath the trees. The sound of light rain heard through open windows often blends with distant environmental noises such as wind, insects, or moving water. Together these layers create soft natural soundscapes that remain consistent without demanding attention. Some rainfall evaporates directly from plant surfaces before ever reaching the soil. Leaves intercept moisture temporarily, and warmth or wind returns part of that water to the atmosphere again. In cooler climates, early morning rain sometimes forms delicate fog above rivers and lakes where water temperatures differ from surrounding air. Thin mist drifts slowly upward from the surface during calm conditions. Rainfall affects the migration of nutrients through ecosystems. Water dissolves minerals in soil, carries organic matter downhill, and redistributes resources gradually across landscapes. The quiet darkness during storms partly comes from thick cloud cover reducing scattered city light and moonlight overhead. Nighttime rain often feels visually softer because fewer sharp contrasts remain visible outdoors. Some birds shake water from their feathers immediately after rainfall using rapid movements that remove droplets efficiently. This helps restore insulation and reduce excess weight before flight. The largest storm systems on Earth can span entire oceans. Within these enormous weather patterns, countless smaller cloud structures continuously form and dissolve while transporting moisture around the planet. Rainwater collecting in tree hollows provides temporary habitats for insects, frogs, and microscopic organisms. Small pools hidden within forests may support tiny ecosystems between storms. Certain grasses release fresh scents during rain because moisture activates oil stored in leaves and stems. These smells become especially noticeable after long dry periods. Clouds near sunset sometimes reflect warm orange or pink light even while producing rain. The combination of cool gray moisture and low golden sunlight creates soft muted evening colors across the sky. Some regions receive more rainfall at night than during daytime because cooling temperatures allow moisture to condense more easily after sunset. Atmospheric stability changes gradually through the evening hours. The movement of rainwater underground can slowly dissolve minerals from rock layers. Springs emerging later at the surface sometimes contain traces of these dissolved materials carried upward from deep underground pathways. Raindrops falling onto dry dust can trap tiny pockets of air inside the soil. This contributes to the soft bubbling sounds occasionally heard during the beginning of storms after very dry weather. Many insects reduce activity during heavy rainfall because flying becomes difficult and dangerous in dense moving water. Sheltered areas beneath leaves and bark provide protection until conditions calm again. The reflective quality of wet leaves often makes forests appear brighter even under cloudy skies. Moist surfaces reflect diffuse light more evenly across the canopy. Some ancient stone temples and structures were designed with drainage systems carefully shaped to guide rainwater away from foundations. Water management has influenced architecture for thousands of years in rainy climates. Rain moving across large open plains may appear as distant gray curtains connecting clouds to the ground. The broad flat landscape allows entire sections of rainfall to remain visible far away beneath the sky. Certain tropical storms release enormous quantities of rain within short periods because warm oceans continuously supply moisture into the atmosphere. These systems convert large amounts of water vapor into rainfall very rapidly. The smell after rain in pine forests often becomes stronger because moisture helps release aromatic compounds from needles, bark, and resin. Cool damp air carries these scents quietly through the trees. Clouds sometimes form wave-like patterns where layers of air move at different speeds. Moisture condenses along these shifting boundaries, creating smooth rolling shapes across the sky. Rainfall influences how animals move through landscapes. Wet ground changes traction, scent trails, and visibility for many species. Some animals become more active while others remain hidden during storms. The steady rhythm of rain can mask unpredictable sounds from the environment. Because sudden noises become less noticeable beneath consistent rainfall, many people experience a greater sense of calm during storms. Some lakes develop visible steam-like mist during cold rain when warmer water beneath releases vapor into cooler air above the surface. Thin layers of drifting moisture form quietly across the water. Raindrops on spider webs sometimes align into evenly spaced beads because tension within the silk redistributes the water naturally along the strands. The atmosphere over rainforests recycles moisture repeatedly. Water evaporates from oceans, falls as rain, rises again through transpiration from trees, and condenses once more into clouds above the forest. A single water molecule may participate in several local rainfall cycles before eventually leaving the region. Certain rocky deserts produce strong earthy scents during rare rainfall because dry minerals and dust release trapped compounds rapidly after becoming wet. The smell can spread across large distances in open landscapes. Rainfall contributes to the slow formation of fertile soil by supporting plant growth and decomposition. Organic matter mixes gradually with weathered rock particles beneath cycles of moisture and drying. The sound of rain against tents or fabric shelters often feels louder than rainfall on solid roofs because flexible surfaces vibrate more easily when struck by droplets. Some tropical leaves are coated with waxy layers that repel water effectively. Rain gathers into rounded droplets and rolls quickly from the surface, helping prevent fungal growth in humid environments. Cloud shadows moving across rainy landscapes create subtle shifts in brightness even during overcast weather. Slight variations in cloud thickness influence how much light reaches the ground. The process of rainfall connects oceans, clouds, rivers, plants, soil, glacier, and living organisms into one continuous planetary cycle. Water moves patiently between these forms without remaining fixed in any single place for very long. In many forests, nighttime rain encourages the sounds of frogs and insects once storms soften into lighter drizzle. Moist air supports activity among species adapted to wet conditions. Rainwater trapped temporarily on flower petals reflects light in curved shapes because droplets act like tiny lenses. Small reflections shift continuously as the droplets move or evaporate. Some regions experience seasonal dry winds followed months later by moist ocean air bringing long-awaited rain. Vegetation, wildlife, and human activity often adapt closely to these repeating atmospheric rhythms. The cool stillness after heavy rainfall partly comes from reduced airborne dust and pollen. Cleaner air and damp surfaces create a softer sensory environment outdoors. Raindrops passing through polluted air may absorb gases and particles during descent. Scientists study rain chemistry to understand environmental conditions and atmospheric changes over time. Certain streams remain dry most of the year but flow briefly after storms refill narrow channels in mountains or deserts. These temporary waterways can appear and disappear within short periods depending on rainfall. The movement of moisture through clouds is extremely complex. Tiny droplets rise, fall, freeze, melt, merge, and separate continuously inside constantly changing air currents. What appears from below as one quiet gray cloud contains endless motion within it. Some storms end gradually with isolated droplets falling from trees and rooftops long after clouds begin opening overhead. The final sounds of rain become slower and softer until only occasional water movement remains in the cool night air. And now the rain grows softer in the distance, settling quietly over rooftops, trees, rivers, and sleeping fields. The clouds continue drifting slowly through the dark sky, carrying cool air and gentle silence across the night. Somewhere beyond the windows, small drops still fall patiently through the calm darkness, steady and unhurried. The world feels slower beneath the rain, softer beneath the clouds, and quieter beneath the long endless rhythm of water moving through the night. Nothing needs attention now. Only the low sound of distant rainfall, the cool quiet air, and the slow peaceful feeling of drifting gradually toward sleep. You have done enough for today. The night can hold everything else until morning. Your thoughts can slow down now, one by one, like soft rain fading into the distance. There is no need to rush through this quiet moment. Rest is part of moving forward. Even the earth becomes still for a while before a new day begins again. So let the mind grow quieter, let the body feel heavier, and let sleep arrive gently in its own calm time.